Hello, all. I want to welcome you again to this lecture. Today we'll be looking at nomenclature of covalent compound. Remember that last time we looked at the ionic compounds. We saw the classes of ionic compounds and we learned how to classify those ionic compounds. So let's take it off from here. Before, as usual, we're going to take the first thing will be to look at this quote. It says, to move the world, we must first move ourselves. This came from Socrates, one of the most intelligent men that ever walked the earth. I'm not going to talk about that. I'll talk about this quote, but I want you to think over it as you relate this with what is going on around you. Let's get it started. What are our learning objectives? The two learning objectives we intend to address here is to understand how covalent compounds are formed. And secondly, we will correctly name and write the formulas of covalent compound, the four classes of covalent compound. All right, let's take it off. You see, a covalent bond. What is a covalent bond? A covalent bond is a type of bond, of course, formed. Remember again, every type of bond is formed so that atoms that come into this association will satisfy the octet rule. In this case, atoms satisfy the octet rule. But simply, what do? They share their valence electron. The word here is share. They share their valence electrons. Now, each valence electron they shared will count into their octet. So what does it mean? A good example we can use always to relate here is that, remember, the Lewis structure of hydrogen, of course, hydrogen in group 1 is 1 dot. Now, it comes into union with another hydrogen 1 dot. And when they come together, they form a hydrogen molecule. This is actually the H2 molecule. What is happening here? What's actually happening here is the hydrogen, they're forming a bond. This single bond is actually equivalent to 2 electrons being shared between 2 atoms of hydrogen. So this attractive force that results when 2 atoms share the electron is what we refer to as covalent bond. And the result of this bond is what? It gives rise to what we call the covalent or the molecular compound. If you don't call them covalent, you can call them molecular compounds. So these are compounds, unlike the ionic compounds that are formed as a result of transfer of electron from metal, which is gained by a non-metal. This involves the sharing of metal. However, this type of bond only occurs between 2 non-metals. Again, let's try to put that. Now, covalent bond only occurs between 2 non-metals, whereas the ionic compound occurs between a metal and a non-metal. So let's look at this. Using pictures is really good to understand perspectives. You see, look at a hydrogen atom. Of course, a hydrogen atom has a nucleus and it's in a cloud of electrons. Now, when these two guys come together, this is just the s orbital where the hydrogen belongs, because it has only just a small orbital. When these two comes together, they form a bigger molecular orbital, whereby both, you see now, if you combine these two, they form a larger sphere, and you see the 2 electrons that are being shared at this point. So these are the electrons that are being shared, which actually corresponds to this covalent bond. So we can imagine a covalent bond to be a kind of tug of war. Look at my picture of tug of war here. Tug of war between 2 people whose powers are equal. You know, when the powers are equal, that kind of tug of war gives rise to a particular type of covalent compound. In fact, we call that type of covalent compound non-polar covalent compound. When the powers of sharing its electrons are exactly equal, we refer to it as a non-polar covalent compound. So what are the 2 types of covalent compound? I've already started talking about this. Now, the one I just talked about is called either pure covalent, non-polar, or ordinary covalent. Now, this results when the sharing of electrons are equal. When the sharing of electrons are equal between the 2 atoms involved. it results to a type of bond we call the non-polar, ordinary, or pure covalent bond. And this is particularly common to the formation of simple molecules, like hydrogen that involves two hydrogen atoms. It makes sense. Two of them are hydrogen atoms, the same weight. They come together, they form this kind of bond. Again, nitrogen, oxygen, and this was what I illustrated in this page. This type of kind of bond is actually what we call a non-polar covalent bond. Non-polar covalent bond, because this bond involves the sharing of atoms between these hydrogens, and the power of these hydrogens are equal. And you can take this to look to be this kind of tug of war. Now, on the other hand, the second type of covalent bond is called the polar covalent bond. In this case, the sharing of electrons are no more equal. In fact, one atom will begin to get this share of electrons than the other one. And that type of covalent bond is what we call polar covalent bond. If you look at the second tug of war I have here, you see this now. In this tug of war, there is no equality here. Here there are, okay, if you look at all these 6 people involved, they are all of the same size. I would assume so. But what is happening here? You find out that there are 4 people here and there are 6 people here. What it simply means is that if they are dragging this tug of war, that these guys to this point are going to win this tug of war. And that is exactly an example of a polar covalent bond. And we can find such examples, something like in a water molecule or in nitrogen, in ammonia molecule. And I have an explanation here. So if you look at this, an example of a water molecule. Here is the Lewis structure. This is actually the Lewis structure of water molecule. Called is the Lewis structure or the molecular structure, whichever way for now. We're going to talk about that later because it's bent. So we can say this is the 3D Lewis structure of water molecule or the molecular shape. Now, this is what we call the space filling methods, telling us the size of the respective atoms involved. Now, this represents, of course, this is oxygen and this is hydrogen. This is hydrogen. This is exactly what I have here. Now, what is happening here? The consequence of polar covalent bond, where atoms do not share where atoms do not get the same share of electron, results to bond polarization, whereby one atom assumes a partial positive and the other atom assumes a partial. So that's exactly what. So this is a bond now. In this bond now, oxygen is getting more, this is getting less, and that makes this bond to be polarized. So, and we're going to talk about this by the time we begin to relate this to electronegativity. Just know at this point in time that the 2 types of covalent bonds are the non-covalent and the polar covalent bond. So, how do we name covalent bonds? How do we name covalent compounds? Sorry for that. Covalent compounds, we're going to divide them into 2 major areas of nomenclature for ease. The first one we'll talk about is the binary covalent compound. Binary covalent compound actually contain, again, we use this in ionic. This binary means 2. So there are those ones that contain 2 non-metals. Of course, 2 non-metals, or it could be a non-metal or a metalloid. Non-metal plus, I'd rather say plus, not or, a metalloid. Plus a metalloid. Remember, metalloid are those ones that share both the characteristics of metals and the non-metals. So they are the ones we call the metalloids. So it could be either between 2 non-metals, or it could be a non-metal plus a metalloid involved in this kind of reaction. So in binary covalent compound, it has to be 2 elements involved, or 2 atoms. So how do we name it? First, you're going to give the name of the first element in full. So you're going to name the first element as though it is a cation, just like we did in ionic compound. Then the second element, you're going to give the name as if you're naming it as what? As an anion. Remember, if you're going to name something as an anion, what it means is that you're going to take the stem name, or what we call the root name, and then add IDE to it. So you're going to drop the last few digits, the last few alphabets, and then use IDE for it. So we name it as a cation. And now, but what stands out is that in nomenclature of covalent compounds are much easier, because I tell students, you should name what you see. To do that, we use special prefixes, which we call the Greek prefixes. The Greek prefixes, which tells you the number of atoms present in these molecules or in this covalent compound. So, of course, 1 means mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Now, if you're going to name them as anion, don't remember, we don't really need this because we don't name them, they are not ions. So what really, the second element, usually, the second element will be named, for the second element, will be named like this. It will be named with an IDE. So we're going to see now, something stands important. One last thing I need to say again is that the prefix mono is not used for the first element. If the first element only contains one element, you don't have to use that prefix. So what do? You just say the name of the element. You don't need to put di or tri. Just say, you say the name of the element. You don't have to put mono because we know it is one already. So by practicing this, we're going to see some examples here. So this one, let's look at this. It says, name the following binary covalent compounds. Remember again, I said this is nitrogen. Of course, that is the name of this guy. Let's write it out. Nitrogen. If you look at your periodic table, this is nitrogen. These are part of the things you need to memorize. You need to memorize a few of these. But if you have your periodic table by your side, you can just get this out. Nitrogen. Now, that's what we have here. But we know we have a 2 here. We're going to come to that. Okay, let me write this well. I'm going to try to write this well, to at least align well. So this is nitrogen. I'm going to give a space. Now the space I left here is where I'm going to put the number. I'm going to give another space. This is oxygen. How do we name oxygen? Remember, we're going to name oxygen what? As oxide. Let's go and look at it. This is oxygen. Oxygen as oxide, because that is the second element. We go back to that again. So what are we going to have? We're going to say oxide. Do I have enough space? Maybe not. Okay, I'm going to move the other way. I don't think I give enough space. Next time, I'm going to rewrite it completely. So, but for now, I'm going to say, still not enough space. I write BX, so I just try to give myself enough space. Okay. So, this is nitrogen and oxide. What is remaining? We need to indicate the number of atoms present. What do? We go to the prefixes. Now, look at the prefixes. How many nitrogen atoms do we have here? We have 2. We go, where is 2? 2 means what? Di. So what do? We're going to put it. So this is going to be di. Oh, that should be closer. I shouldn't write it differently. Should be. I should use small letter for this because it's making it look as safe. So I'm going to be this. Okay. I'll go back. Sorry for that. So this is my nitrogen again. So remember, what I have here is di, 2 nitrogen. So I'm going to go put di, nitrogen. So now what it means, I have 2 nitrogen. How many oxygen do I have here? 5. I go, look where is 5. 5 again. Penta. So I'm going to put it here. You give a space. You now say pentaoxide. So the name of this compound is dinitrogen pentaoxide. Let's go to the next one. For this one, we go back. C, again, if you look at the periodic table, C is carbon. We say carbon. Carbon here is, how many carbon do we have here? 1. Remember the last rule I gave you? I said, if the first element is just 1, you do not need to use mono. So we're not going to use mono. So we're going to just say carbon. How many do we have here? This is 2 again. And 2 is di. Remember, this is 2. So we're going to say carbon di. Sulfur. How do you name sulfur again? Remember, you're going to name sulfur as what? Sulfide. Call it carbon disulfide. Now, for this one, we go back. Now, the silicon. Remember, we said it can be between a metalloid or a non-metal. That's exactly what we add now. This is a metalloid. And no, this is silicon. How many silicon atoms do we have there? 3. So we go to 3. 3 means what? Tri. So we're going to say tri-silicon. How many? This is called what? Hydrogen. Here, hydrogen is, if you put ID, it becomes what? hydride. But how many of it do we have there? Let's go back. We have 7 of it, and 7 is hepta. So it's going to be trisilicon hepta. Hepta is not, and I need to put a space there. So it's going to be hepta hydride. So that is how you name this compound. Let's go to the next one. Now again, I look at this one. I say name the following two the same way: binary ionic compound. This is xenon. Here, xenon is number 1. You just put xenon because it's number 1. You don't say monoxenon. 6 atoms. Again, you go to 6. Here we have 6. 6 means hexa. So we're going to say xenon hexa. This is chlorine. Chlorine is named after chloride. Hexachloride. That is the name of this compound. Again, this is nitrogen. Put the name nitrogen. I'm going to, first of all, now I'm going to be putting it directly because you already know what to do. You can always pause the video, practice this, and come back and check your answers for comprehension and correctness. Nitrogen, there are 2 atoms. So it's going to be dinitrogen. 4 means tetra. Let's go to 4. 4 means tetra. So this is tetrafluoride. Fluorine, if you put ID to it, becomes fluoride. Again, we go to the last one, the next one, selenium. This is selenium. Selenium has only 1 here, so no need to put mono. We're going to just say selenium. How many do we have here? 8 atoms of selenium, and 8 means what? Octa. So it's going to be octa. How many bromine atoms? It's going to be as bromide. So it's going to be octa bromide. That is the name of this compound. So now what we just did was we got the formulas of elements, formulas of this compound, and we're able to name them. So what if we were given the names and asked to do what? If we're given the names and we're not asked in problem 3 now, we're given the names and we're going to ask to move it back to the formula. So again, I tell students, name what you see or what you hear. Again, the Greek prefixes will come into play again. Di means 2, so it's dihydrogen. Hydrogen is the first element. So we're going to say H, di means 2. H, remember you cannot say the 2 has to be a subscript. So it's going to be H2, dihydrogen, sulfide. Look at that. Sulfur is 1. So I tell students, some textbook will tell you to put mono. Some will not. Particularly in the case of this sulfide, they don't usually put it. So, but that is fine. In the next one you do, apart from this and the second element, you need to put the mono. I think I would say, okay, this is dihydrogen, supposed to be monosulfide. I think this is my mistake. This is monosulfide. So this is dihydrogen monosulfide. So that was my mistake. Sorry for that. So I had to put mono there. So I'm going to try to clean out this. Make it clean. This is monosulfide. Sorry for that. I'm going to put this and then we name it. Let's now write it. So dinitrogen monosulfide. Sulfide is only 1. So we're going to put H2S. And that will be the name of that guy. Now for the next one, it says diarsenic. You look at your periodic table. The arsenic is As. But how many do we have there? 2 arsenic. So it's going to be As2. And then the next one, this is diarsenic. That's what we have here. Penta. Penta simply means 5. You can always refer to, remember in the exam, you're not going to be given these prefixes, but you can always go back for now as you're practicing and look at them and use them for practice. So penta means 5. Pentaselenide. So I'm going to say S. Remember, I say diarsenic pentaselenide. Selenium is Se. And how many atoms do we have there? 5. I'm going to put 5 at this point. The next problem, it says silicon tetrabromide. Again, silicon is Si. And it's only 1. Remember, the first element, when it is just 1, you don't put mono. But in the last element, you have to put it. Then tetrabromide. Remember, we have bromide means we have bromine atom. And how many? Tetra simply means what? 4. So this becomes the formula of that compound. We go to the next one. Again, we are now writing formulas from name of this compound. So again, try selenium. Selenium is Se. 3 atoms is going to be 3. This means 3. Bromide. Bromine again. How many? Hexa means what? 6. At this point, you should be memorizing it. Now, I want to say something with this problem. Now, when we did the ionic compound, I told you that you have to always simplify. If it was an ionic compound, if it was a metal here now, would have simplified by dividing both sides by 3. But you do not need to simplify. You do not simplify ionic compound. You don't simplify ionic compound. I just have to say that's why I put this problem. Now, the next one, diboron. Boron is B. How many atoms? Di means 2 atoms. Trinitride. Nitride means how many? So diboron, trinitride. Tri means 3. And nitride means nitrogen. And since we have tri, it's going to be 3. This means 3. Trinitride. Again, we go to phosphorus. Like I said, you can always pause this video, try this thing yourself, and come back to them and see how much you can do. That helps a lot. The next one, phosphorus. Phosphorus is the next element. When they say phosphorus alone without anything attached, it tells us that phosphorus is only 1 atom. Phosphorus, and then pentaiodide. That's what we have here. Phosphorus pentaiodide. What it means is that we have iodine here. How many do we have? 5 iodine. Penta means 5. We'll go there and put it. So this is the formula of this compound. So, and then we come to an end of naming binary ionic compound. The next one we'll be talking about will be, how do we name acid? Acid actually are polar molecules, and the good thing about them is that they behave like ionic compounds because they have ionizable hydrogen ions they can easily release. They have these hydrogen ions that they can easily donate and makes them behave like ionic compounds. So what usually happens is that in any formula where you see an acid, if you see an acid, the hydrogen, H, is always written first. Anytime you see a molecule with hydrogen first, that molecule is an acid. Is an acid. Now, that will preclude some atomic, some binary covalent compounds that start with hydrogen. So this one, the hydrogen must be an ionizable hydrogen. Now, but we're going to get into much of this in the later modules of this class. So there are 2 of them. The binary ones, again, we come to binary, the same and keep coming on. Binary means they contain 2 elements. So what it means, they contain a hydrogen and another element. There must be a hydrogen first because that's the constant thing about every acid. And then they have to have a hydrogen and another element. Now, so if a good example here is what we have HCl here. There's a hydrogen and another element. How do we name it? You want to name it, you have to add hydro, representing this first hydrogen I have here at the beginning of the name. And then you now change the anion. Remember before, we would have said chloride. But now you're not saying chloride. You're going to change the ending of that IDE to RIC. You just put an IC to that name. So look at what you do. You now put an IC to that name. So if I'm going to name this guy now, it's going to be hydrochloric acid. So you have to put IC. And at the end of the name, you have to put acid to their name to show that the acid. Now, on the other ones we're going to be talking about, we call them the polyatomic or the ternary or the oxy acid. Now, these ones, again, like I said, they will always have hydrogen in front of them. However, they contain the usual polyatomic ions that we encountered in ionic compounds. So it is going to be a polyatomic anion combined with the hydrogen. A good example is this one. We call this the nitric acid now. In nitric acid, we have a hydrogen combining with a nitrate ion. Remember, the hydrogen here is positive ion combined with a nitrate. If you put them together, it's going to form this. And this is, so how do you name it? The name of these gas are simple. You drop the name, hydro doesn't come in. You just name you just bring forth the name of the anion, the polyatomic ion. So this is nitrate. What do? You just, since you know it's nitrate, you drop the ATE in the name and put IC, and then put the name acid. Remember, for every acid, acid must always end the name. So I usually tell the student, acid is the last name for all these guys that belong in acid. So we're going to name this one as, this is nitrate. So we're going to drop ATE. We're going to put IC. So the name of this is nitric acid. So we're going to practice this in the next few pages. So it said, name the following binary acid. Again, remember, the first thing you need to do, you name them as hydro. This is the first ones, hydro. Then you drop the distance. So remember, this is, we'll put hydro in the first place. Hydro, that's the first thing. Now, remember, this is iodine. So iodine would have been, the iodide ion is iodide. But now, this is not what we're doing. We're not going to remove this DE and replace it with what? Let me use another color for that. With IC. If you take this IC and put here, what are we going to have? We're going to have hydro, iodic, and then you put acid. And that will be the name of this acid. If you apply this to the other one, so this is going to be, this is still binary acid, 2 elements, hydro, sulfuric acid. If we take that to this one too, again, this is hydro. Then this is fluoride. We're going to drop the IDE, DE, and put what? IC. So it's going to be hydro, fluoric, hydrofluoric. Let me put that fluoric well. FLUO, fluoric acid. And that is how you name these ones. Now, the last but not the least in this model will be naming those polyatomic acid, or we call them ternary acid, or the oxy acid. In fact, the reason why we call them the oxy, remember that all these anions, all these polyatomic anions contain oxygen. When you look at all of them, apart from ammonia, of course, that is a poly, the only positive guy among them. Every other one in this group contain oxygen. That is why we call them oxy acid, or this is also called oxy anions. You can call this the oxy anions, of course, minus the ammonia. So now let's remember that. So this is, remember the rule. You are not saying, you don't have any business by saying hydro here, because these guys are contain polyatomic ion. So you are saying just the name of the polyatomic. So what is the name of this polyatomic ion? This is sulfate. We go down there, we look at it. This is, okay, let me highlight that to be clear. This is, sorry, I didn't get that. This is sulfate. So what are we going to do? Now, we know this is sulfate. But that's not what we're going to say. What are we going to do? We're going to drop this. We're going to drop this ATE and put IC, remember. So it's going to be what? So now I'm going to drop it. So I'm going to drop this guy. So what I'm going to do, so the name of this is going to be sulfuric, put IC, acid. Sulfuric acid. The same thing goes here. This is phosphate. Phosphate, look at it here. Phosphate is there. I can use another color to highlight that. If I go to my highlighter, let me choose green. This is the phosphate. So if you look at the phosphate there, now let me go back to this. For the phosphate, so we're going to drop the ATE and put ICE. So, and then remember, no mention of the hydrogen. What are we going to call it? We're going to call this phosphoric acid. That is how we name this. And the last but not the least, we look at the carbonate. Where is the carbonate? Let's look at it. Okay, look at the carbonate here. You are supposed to memorize. Now, the ions you needed to memorize will be found in a worksheet I give you. But for practice, I tell students, try to practice with all of them so that you can be versatile when this nomenclature comes up. So this is carbonate. So how are we going to name this? Remember, you're not going to say hydrogen. This is a carbonate. You're just going to remove the ATE in carbonate and put IC and then put your acid. So this is going to be carbonic acid, and that is the name of properties. So this is the end of this class. I would advise you to always go back to my worksheet to practice some more. And as usual, again, if you have any questions, do not hesitate to contact me through the usual channel. Either come to my office or send me an email. Thank you for listening and do have a wonderful day. And bye.